Hola, this is Ina Villegas, and my topic is all about planets and their moons. So, let's start. So, this is my objectives to gain knowledge about solar system, to distinguish between the terrestrial and Jovian planets, to discuss the characteristics of Mercury, explains the effect of atmosphere on the climate change of a planet, review the findings of Spirit and Opportunity on Mars, compare the appearance of craters on Mercury to those on Earth and Venus, give examples of tectonic activity on Venus, discuss the origin and formation of the Moon, describe the composition of the rings of Saturn, discuss the classification of the Pluto as a dwarf planet, compare asteroids, comets, and meteorites. So we have the solar system. The solar system formed about 4.6 billion years ago from a cold, diffuse cloud of dust and gas rotating slowly in space. The cloud was composed of about 92% hydrogen and 7.8% helium, about the same elemental composition as the universe. Solar system consisted of all naturally occurring elements heavier than helium, including lithium, carbon, oxygen, iron, gold, uranium, and etc. These heavier elements had formed by fusion of hydrogen and helium along with some of the heavier elements themselves in the centers of the stars that had since exploded. A portion of the cloud gravitated toward its center to form the sun. Here the pressure became so intense that hydrogen fused, producing energy as some of the hydrogen converted to helium. Escape velocity. Any objects, including a rocket ship or a gas molecule, can escape from a planet's gravity when it reaches a speed known as the escape velocity. The escape velocity is proportional to the mass and hence the gravitational force of the planet. So, the escape velocity, the speed that an object must attain to escape the gravitational field of a planet or other object in space. Solar wind. Solar wind is a stream of electrons and positive ions radiating outward from the sun at high speed, blew even more gases away from the primordial planets. Terrestrial planets, Mercury, Venus, Earth, and Mars, lost most of their gases, leaving behind spheres composed mostly of non-volatile metals and silicate rocks. These four are now called the terrestrial planets. Jovian planets, the protoplanets in the outer reaches of the solar system, were so far from the sun that they were initially cool. As a result, the outer Jovian planets, Jupiter, Saturn, Uranus, and Neptune. About 5 years ago, exploding stars accelerated dust and gas into the great void of space. So the first one with the arrow, small portion of one of these vast clouds began to rotate and contract under the influence of gravity. The second one is the cloud continued to rotate and contract and flattened into a thin disk, matter concentrated to the center, forming a protosun. The third one, as the sun contracted and became denser, matter and the outlying disk coalesced to form the planets. So this is a schematic view of a modern solar system. The planets drawn to scale, the terrestrial planets are so small in this scale that they are enlarged below. The Jovian planets, right, are predominantly composed of gases and liquids with small rocky and metallic cores, while the terrestrial planets below are they composed primarily of rock and metal. The planets and sun drawn to scale note that the Earth Moon orbital system would easily fit into a portion of the sun's surface. The Earth is the most massive of the terrestrial planets, but is only 1 over 300 the mass of Jupiter. Saturn rings would reach from the Earth to the Moon. Next, atmosphere and climates of the terrestrial planets. So we have Mercury, the closest planet to the Sun and therefore initially the hottest, as lost initially all of its atmosphere. Mercury make a complete circuit around the Sun faster than any planet. Each Mercular year is only about 88 Earth days long. In 1991, radar images of Mercury revealed highly reflective regions at the planet's poles. Data indicated that these regions were composed of ice. Mercury's spin axis is almost perpendicular to its orbital plane around the Sun, so the Sun never rises or sets at the poles but remains low on the horizon throughout the year because the sun is so low in the sky. Next, we have Venus. Closely resembles Earth in size, density, and distance from the sun. As a result, Venus and the Earth probably had similar atmosphere early in their history. Next, Earth. Outgassing from the mantle modified the primordial atmosphere as life evolved. Complex interactions among the geosphere, hydrosphere, and biosphere further altered the atmosphere, creating conditions favorable for life. Mars, the fourth planet from the Sun, is frigid and dry. The surface temperature averages 56 degrees Celsius and never warms up enough to melt the ice. Spirit and Opportunity. Spirit, one of the two mobile robots that landed on Mars in 2004. Opportunity, one of two mobile robots that landed on Mars in 2004. In January 2004, NASA landed two mobile robots called the Spirit and Opportunity. On the Martian surface, each robot was equipped with six wheels and drive system communication equipment to receive instructions from Earth and transmit data and solar panels for power. One of the main functions of these rovers was to look for evidence of the existence of water in the Martian past. The Spirit rover landed on the dry crater and did not detect any evidence of water. However, the rover Opportunity discovered layered sedimentary rocks near its landing site. So, this is what it looks like. Geology and tectonics of the terrestrial planets. Mercury. Little was known about the surface of Mercury before the spring of 1974, when the spacecraft Mariner 10 passed within a few hundred kilometers of the planet. Images relayed to Earth revealed a crater surface remarkably similar to that of our moon. So, for many years, scientists presumed that any water had been part of Mercury or its early atmosphere had long boiled off. This presumption was shown to be incorrect, however, by NASA's Messenger spacecraft, which was launched in 2004 and took 5 years to reach Mercury and used close flybys of Earth once and Venus twice, and the gravity of these planets reached Mercury on January 14, 2008. So, Mercury has a cratered surface. The craters are remarkably well preserved because there is no erosion or tectonic activity on Mercury. The photograph shows an area 580 kilometers from side to side. Venus. Astronomers use spacecraft based radar to penetrate the Venusian atmosphere and produce photo like images of its surface. Gravity studies, also conducted by spacecraft, are used to infer the density of rocks near the Venusian surface. James Head, Magellan investigator, suggests that a catastrophic series of the volcanic eruptions occurred 300 to 500 million years ago, creating volcanic mountains and covering much of the surface with basalt flow. Head concludes the planet's entire crust and lithosphere turned itself over. It certainly makes a strong case that catastrophic events are in the geological records of planets. and it ought to make us think about the possibilities of such catastrophic events in Earth past. An alternative hypothesis contends that the resurfacing occurred more slowly. Crater abundance indicate that most tectonic activity on Venus stopped after the intense volcanic activity 300 to 500 million years ago. According to this model, rising mantle plumes generated magma that prepared the planet in a short time with rapid series of cataclysmic volcanic eruptions. Crater abundance indicate that most tectonic activity on Venus stopped after the intense volcanic activity 300 to 500 million years ago. Some evidence indicates that volcanic activity has ceased permanently because the planet interior cooled. Some geologists have suggested the term blob tectonics to describe Venusian tectonics because Venus is dominated by rising and sinking of the mantle and crust. Earth. Earth is large enough to have retained considerable internal heat. This heat drives convection within the mantle that produces tectonic motion. In turn, Earth tectonics continuously reshapes the surface of our planet and is partially responsible for the atmosphere that sustains us. Mars. The Martian surface consists of old, heavily cratered plains and younger regions that have been altered by tectonic activity. Lava flows much like on Venus, and the moon covered the plains. The Tarshish Bulge is the largest plain, crowned by Olympus Mons, the largest volcano in the solar system. Olympus Mons is nearly 3 times higher than Mount Everest, with a height of 25 kilometers and a diameter of 500 kilometers. Its central crater is so big that Manhattan Island would easily fit inside. So the lower picture or photo is the Olympus Mons. The Moon, our nearest neighbor. Most planets have small orbiting satellites called moons. The Earth's moon is close enough so that we can see some of its surface features with the naked eye. Galileo studied the moon with a telescope and mapped its mountain ranges, craters, and plains. Galileo thought that plains were oceans and called Maria. The word Maria is still used today, although we know that these regions are dry, barren, flat expanses of volcanic rock. So, what's the history of the moon? The moon formed about 4.45 to 4.5 billion years ago, shortly after Earth. So much energy was released during the moon's rapid accretion that as the lunar sphere grew, it melted to a depth of a few hundred kilometers, forming a magma ocean. Meteorite bombardment kept the moon's outermost layer molten. Meteorite bombardment diminished enough for the moon's surface to cool. The igneous rocks of the lunar highlands are about 4.4 billion years old, indicating that the highlands were solid by that. So we have here the pictures formation of the moon. So A, according to the most widely held hypothesis, the moon was formed about your 4.5 billion years ago when a Mars-sized object struck Earth, blasting a cloud of vaporized rock into orbit. The vaporized rock rapidly coalesced to form the moon. The second picture, B, during its first zero point 0.6 billion years, intense meteorite bombardment cratered the moon's surface. So, in the letter C, the third picture, the dark, flat Maria formed about 3.8 billion years ago as lava flows spread across portions of the surface. Today, all volcanic activity has ceased. The Jovian planets, size, composition, and atmosphere. So we have Jupiter is the largest planet in the solar system, 71,000 kilometers in radius, It is composed mainly of hydrogen and helium, similar to the composition of the Sun. However, Jupiter is not quite massive enough to generate fusion temperature. So it never became a star. Jupiter has no solid rocky crust on which an astronaut could land or walk. Instead, its surface is a vast sea, 12,000 kilometers deep, made of cold liquid molecular hydrogen and atomic helium. Under these extreme conditions, hydrogen molecules dissociate to form atoms. Pressure forces the atoms together so tightly that the electrons move freely throughout the packed nuclei, much as electrons travel freely among metal atoms. As a result, the hydrogen conducts electricity and is called metallic, liquid metallic hydrogen. More than 300 years ago, two European astronomers reported seeing what came to be called the Great Red Spot on the surface of Jupiter. Liquid metallic hydrogen, a form of hydrogen under extreme temperature and pressure, which forces dead atoms together so tightly that the electrons move freely throughout the packed nuclei, and as a result, the hydrogen conducts electricity. Great Red Spot, a giant hurricane-like storm on the surface of the Jupiter that has existed for centuries. Jupiter consists of four main layers: a turbulent atmosphere, a sea consisting mainly of liquid, molecular hydrogen with a smaller amount of atomic helium, a layer of liquid metallic hydrogen, and a rocky metallic core. Earth is drawn to scale on the left. Saturn, the second largest planet, is similar to Jupiter. It has the lowest density of all the planets, so low that the entire planet would float on water if there was a basin of water large enough to hold it. Such a low density implies that, like Jupiter, it must a relatively small core of rock and metal. In fact, in many ways, Saturn and Jupiter are alike. Saturn has long been famous for its rings, which are visible with a high quality amateur telescope. Uranus and Neptune are so distant and faint that they were unknown to ancient astronomers. The Voyager 2nd spacecraft, launched in 1997, flew by Jupiter in 1979 and by Saturn in 1981. Both Uranus and Neptune are enveloped by thick atmosphere composed primarily of hydrogen and helium, with smaller amount of carbon, nitrogen, and oxygen compounds. We have here the moons of the Jovian planets, the moons of Jupiter. In 1610, Galileo discovered four tiny peaks of light orbiting Jupiter. He reasoned that they must be satellites of the giant planet. 1999, astronomers had identified 16 moons orbiting Jupiter. By 2009, 62 were known. The fours discovered by Galileo, referred to as the Galilean moons, are the largest and most widely studied: Io, Europa, Ganymede, and Callisto. Europa, the second closest of the Jupiter's moons. Europa is similar to Earth in that much interior is composed of rock and much its surface is covered with water. Ganymede and Callisto, the Galileo spacecraft, measured a magnetic field on Ganymede, indicating that this moon has a convecting metallic core. Other measurements imply that the core is surrounded by a silicate mantle covered by a water or ice crust. Saturn moons: 62 orbit Saturn, Saturn's largest moon. Titan is larger than the planet Mercury. Titan unique because it is the only moon in the solar system with an appreciable atmosphere. This atmosphere has been retained because Titan is relatively massive and extremely cold. The moons of Uranus and Neptune. 27 known moons orbit Uranus. Several of the moons are small and irregularly shaped, indicating that they may be debris from a collision with a smaller planet or moon. Neptune has at least 13 moons. The largest is the Triton, which is about 75% rock and 25% ice. Planetary rings. Saturn rings are composed of dust, rock, and ice. The particles in the outer rings are only a few 10,000ths of centimeter in diameter, but the innermost rings contain chunks as large as a flying barn. Saturn rings may be fragments of a moon that never coalesced. Alternatively, they may be the remnants of the moon that formed and was then ripped apart by Saturn's gravitational field. If the moon were close enough to its planet, the tidal effects would be greater than the gravitational attraction holding the moon together, and it would break up. Thus, a solid moon cannot exist too close to a planet. Images from Cassini spacecraft show that the gravitational force from Saturn's moon have herded the ring particles into intricate spiral and twists. Pluto and the other dwarf planets. Pluto has been a controversial figure in our solar system. It has been grouped with similar space objects as dwarf planet. A new classification to be described at the end of this section. Pluto has three moons: Nix, Hydra, and Charon. Nix and Hydra are very small, but Charon is nearly half of Pluto's diameter. It may be related to numerous similar icy bodies that are part of the Kuiper Belt. These Kuiper Belt objects are residual planetesimal left over from the formation of the solar system. Kuiper Belt objects, tiny ice dwarfs similar to Pluto orbiting in a disk-shaped region at the outer reaches of the solar system. Asteroids, comets, and meteoroids. Asteroids, astronomers discovered a wide ring between the orbits of Mars and Jupiter that contained tens of thousands of small orbiting bodies called asteroids. The orbit of the asteroid is not permanent like that of a planet. Comets. Occasionally, a glowing object appears in the sky, travels slowly around the Sun in an elongated elliptical orbit, and then disappears into space. Such an object is called a comet. After a Greek word for a long haired, the comet consists of a dense, solid nucleus, a bright outer sheath called a coma, and a long tail. Coma, the bright outer sheath of a comet surrounding the nucleus. Tail, the long trailer portion of a comet, always pointing away from the sun. Form when the solar winds blow away lighter particles from the comet's head. What appears to be a fiery arrow is actually reflected light from the sun. A meteor that strikes Earth's surface is called a meteorite. Most meteorites are stony meteorites and are composed of 90% silicate rock and 10% iron and nickel. Most stony meteorites contain small grains about 1 millimeter in a diameter called chondrules, which contain organic molecules including amino acids, the building blocks of protein. Meteoroids, as 10,000 asteroids race through the solar system in changing paths, many collide and break apart, forming smaller fragments and pieces of dust. A meteoroid is an asteroid or fragment of a comet that orbits through the inner solar system. Friction with the atmosphere heats it until it glows. To our eyes, it's a fiery streak in the sky, which we call a meteor, or colloquially a shooting star. Most meteors are barely larger than a grain of sand when they enter the atmosphere and vaporize completely during their descent. Larger ones, however, may reach Earth's surface. A meteor that strikes Earth's surface is called a meteor. And that's the end of our discussion. It's my pleasure if you learned something about this topic. Thank you for listening and have a good day today. Again, this is Ina Villegas from BSED Science, SC11.